For okay, a real estate company keeps a register of the monthly cost of rent R of their apartments and their corresponding area. Okay. In square meters. Do you see the entire thing? Sorry, I'm just going to make it visible better. Okay, it jumps like that. Okay. So the areas of the apartments registered are summarized in the following box and whisker diagram. Very well, very well. By the way, I realized I bumped into these whisker diagrams before in IB papers, and I couldn't find anything on them in the IB book, even the HL book. Thank God you can find information about them elsewhere. But the thing is that they're defined differently in different sources. So, for example, the length of these whiskers, sometimes it's 2 times, sometimes 1.5 times the what do you call this distance here? Now let's see what we can get from this. The areas of the apartments registered summarized in the following box and whisker diagram. Okay. Find the smallest area that would not be considered an outlier. So yeah, that's exactly the kind of stuff where you would probably see differences in definitions, but usually the whisker, the lowest point of the whisker, so this one will usually determine the boundary for outliers. So in this case, I'd say that 21 is the smallest area that would not be considered an outlier. So if you have anything smaller than this or larger than this, that would be considered an outlier. Okay, the regression line A on R is this. Okay, so if we estimate the area from the rent, we get this this line, but the regression line of R on A is this. Okay, very good, very well. So if we estimate the rent from the area, we get a little bit of a different line, and that's, well, not a little bit, much different, but if you transpose or like mirror it, should be approximately the same line, but it's not the same line. Okay. By the way, the intersection of these lines is the mean. From the intersection of that line, you see the mean of both of these variables, which is not an easy thing to see, and I could not find that in any of the books because I've seen a similar exercise before. So I guess, I mean, if you don't watch my video, I don't know how else would you know that. Maybe it's a little bit arrogant to say that, but really, it looks like these kind of exercises are popping up a lot. So especially in HL, so just, guys, memorize the fact that the intersection of these two lines, when you take a regression line of one variable on the other one and vice versa, and then you take the intersection of these two lines, you get the means of both variables. You can get it from the expressions for these coefficients, but it's very complex. These coefficients are calculated as products of sums of these means from the data set, and how it's done. But from these equations, you can actually solve that. When you take the intersection of these lines, it's going to be mean. Okay, let's see. Yeah, and so in this last question, they actually ask for it. So I'm not sure how you were supposed to know that. Well, I didn't find that information in the basic IB book. Okay, one of the apartments has a monthly rent of 480. Estimate the area of the rental. Okay, so when we estimate the area from the price, then you would plug in the rent here. Sorry. Oh, sorry. Okay, maybe this is better this way. So we plug the rent into So let me just do it. Oops, sorry. Now things are moving around. Okay, so 180, and we plug it in. I write this approximation sign because we are estimating. These are estimations, they're never precise. Times 100, 480, and minus 50. Okay, so the easiest would be to divide 480 by 12 first. If I divide it by 2, it's going to be 240. Very good. 240 is 2 times 120, so it's 20 times 12. So this should be 40 times 12, which means that when I divide by 20, I get 40, and 40 times 12 is 480, so I'm right. So this is going to be 5 times 40 minus 50, which is 200 minus 50, which is 150. Yay, that's bigger than my apartment. And then find the mean rental cost of all the rental estate companies' apartments. So what I'm going to do, I'm going to use the knowledge which I shared with you, and is that the mean will be in the intersection of these two lines. Is going to be in the intersection of these two lines. Okay, what does it mean, intersection of these two lines? It means that, well, it's some point which satisfies both of these equations. So it's basically the solution to the pair of equations, this and this simultaneously. Okay, how do we solve this? I mean, perhaps the easiest is to just substitute R into the first. I mean, there are many ways to do this. We can like sum them up. That doesn't, I'm just looking at these fractions, that are they in some sort of form that it's easy to subtract them from each other or multiply them by each other, but they don't seem to be exactly of any of that kind of form. So I think it's the easiest is to just substitute the R from the lower equation into the upper equation. So then we get that A equals 5/12. And now you will see this only if you are on YouTube. Actually, I'm going to move this here and let's do it. Okay, so R is this minus 50. So I just substituted this R from the lower equation into the upper equation, and then we just calculate. So first multiply these, just opening the brackets, so it's going to be 25 divided by 24. Okay, A plus, and then 5 times 100 divided by 12. I'm not going to calculate this because it looks like it's not going to be an integer, and then minus 50, and so from this we can solve A. From this we can solve A by subtracting this, so we have that. Oh, interesting. That's actually, yeah. So 1 minus this is minus 1/24. Oops. Right, because here we have 1 minus this is 24/24 minus 25/24, which is minus 1/24 A, and is equal to this. And so multiplying, now I see it was a good idea not to calculate this, because now it will be cancelled. So let me just write it 500 divided by 12 minus 50, but now multiplying by minus 24, what we get that A equals now minus 500, but like 24 divided by 12 is 2, so we just get 2 times 500, and minus minus is plus 24 times 50, which is minus 1000, plus 24 times 50 is the same thing as 24 times 100, and then divided by 2, which is the same thing as 12 times 100, which is 1200. And so this is just 200. Okay. So A is 200. Is that a reasonable average area? Well, probably. I mean, it's pretty large, but why not? Maybe that's an average area for this company. And we can see soon when we plug this into R, and we will see whether this matches our solution to the part B of the exercise, where we had that a 150 square meter apartment would cost about $480. So I would expect now that R should be approximately 600. That, by the way, very cheap for such a big apartment, especially if you live here in Helsinki. Okay. Okay, so how did I make a mistake? I think I made a mistake because I don't think so. Yeah, so yeah, no, I didn't make a mistake. It's just so funny that it's so cheap. That's why I thought I made a mistake. Okay. Substituting 200 into here will make, okay, so it's immediately divided by 2, which makes it just 100. So R is going to be 5 times 100, which is 500, plus, oh, that's exactly 600, like just like I said that it would be. Okay, so this is my solution. The average rental cost is 600, and the average area, which by the way they did not ask, so we should never give the answers for things they didn't ask for. So we just give the rent, which is the average rent is 600.